Very well, at this point, what we want to explain is how the IGBTs are powered with 15 volts, or rather, what is the path of those 15 volts. So, we are going to follow up. This is going to be brief, but the idea is that you can identify and recognize them. There is a component in that area that is often damaged, and when this component is damaged, we have an error in the IPM, but the IPM is not the problem, but the component that is responsible for maintaining those 15 volts constantly. Let's observe it in the following way and see if we can identify it. Let's go this way, leaving the switch mode power supply. Let's zoom in on this area. There it is, here where we have the transformer and the other side of the switch. Starting from here is where we generate the 15 volts. These 15 volts, notice that we even have a checkpoint here. Here we have the 15 volts. They are derived on one side to this point. This is the fan inverter connection socket. We will talk about that later. And notice that these 15 volts follow a path. I went off the camera, sorry. They follow a path and reach these points. These points are for transfers. Through these perforations in the board, the voltage is allowed to pass to the other side of the board when they are double-sided base plates. Now we are going to the other side. Arrived at this point, in this area. Let's see if we can put a little more light. What is done now is to go from here to these points that feed the capacitors. These capacitors that we are seeing here are responsible for maintaining the 15 volts to power the IGBTs. These are the capacitors that maintain those constant 15 volts that will be injected into each IGBT as appropriate. An error or deficiency in these capacitors will cause us to have an IPM, motor, or overcurrent error. We will not have an error on the board that tells us the IGBT power capacitors failed. No, this error we will have to deduce ourselves when the problem is in the motor or IPM area. So, if we control that the IPM is in good condition, we can move on to checking these capacitors, and it may be that we find the problem there. Well, these capacitors are type SMD. This means that they are soldered on one side of the board, they do not pass through to the other side. So, to disassemble them, we have to heat with the soldering iron in this point and in this one. And these capacitors come out. Later, in the soldering practice, we will be explaining how to use solder and a soldering iron. So, don't worry about that. Well, the problem with these capacitors is that they are in different parts of the board. For example, in the case of this board, we can make a measurement of those 15 volts that is located in this checkpoint without disassembling the entire equipment completely. Just by opening the outdoor unit, we already have this area exposed. We can do a test between 15 volts and GND in some checkpoints, and we will see that we have the 15 volts. But to know that those 15 volts do not fall on the IGBT power point is complicated because our test point is on the other side. So, in these boards, it gets quite complicated. Unless we identify the 15 volt points on the IPM, but for that we would even need to know what model of IPM we have here. So, these capacitors are complicated to check on these types of boards. So, if we suspect that there is this problem, we have to remove the board and test it outside. When we see the test of the complete operation of the equipment, we will be seeing how to measure those 15 volts with the equipment assembled, but in a model that can be reviewed, which is the one I will show you next. We will see the board of an LG inverter and see that the power capacitors of this LG are very visible. In fact, if we look at the board from above, at this point we will already have the test points of those 15 volt capacitors. Clearly there are capacitors here that go directly to power the IPM that is in this area. In this case, we can measure the 15 volts without completely disassembling the equipment, not even taking out the board. And here are the capacitors that keep those 15 volts. Moreover, they are much simpler capacitors. I will now show you a Carrier brand board that is a Medea board installed in a Carrier or Medea unit as well. We will see that those capacitors are even more complicated to check. One moment, please. Let's see then a Medea electronic board. Let's see if we find the image where it is clearly visible. There it is. Please observe here. To access these capacitors, we even have to remove the heat sink. This is a board viewed from the bottom but with the heat sink uninstalled. In these models, we even have to uninstall the heat sink. So it's even more complicated. But well, know that it exists. That we have to test their capacity to be correct. And that the best thing is to see if those 15 volts are maintained there or a little less with the equipment in operation. When it is working, a little less than 15 has to be maintained. Well, then know that this is there and that they tend to fail quite a bit. Not only in inverter air conditioning, but also in refrigerators, fridges, or refrigerators. Excellent. Having seen this, we will move on to the following topics. Please leave a comment if you have any questions.